Page 61, we're looking at solving quadratic equations by factoring. Before we even talk about that, though, I just want to go over one more time what the difference is between writing a quadratic in a standard way or writing a quadratic in a factored way. So a standard form would look like ax squared plus bx plus c, where a, b, and c are integers. And factored form would look like, we'll say, x minus r times x minus s. And this is just really the same thing, but this is where r and s also represent integers. So we've learned how to change them from one form to the other. But how can factoring a quadratic help you solve an equation when it's a quadratic equation? So when you're solving a quadratic equation, first of all, there are three possible outcomes. One of them is one solution, which can happen. One is two solutions, and the other one is no solution. Those are three things that can possibly happen. So what we're going to do is we're going to use the multiplicative property of 0, and that basically states if you multiply anything by 0, the outcome is going to be 0. So right here I have two things that I'm multiplying, and this happens to be a quadratic in factored form. Remember, if this was just an arbitrary two factors and I set it equal to 0, this can only be true if A is equal to 0 or B is equal to 0, and I want you to relate A to possibly this factor and relate B to this factor. I ask myself, what would I plug into X to make that factor 0? And that would have to be positive 1. I also am going to look to see what I could plug into the second factor to see what value of X would make that factor be equal to 0, and that's negative 4. This is us using the multiplicative property of 0 to find that this quadratic has two solutions, 1 and negative 4. I can do this when a quadratic is in standard form, but I have to change it to factored form first. So what I have to do is go ahead and I'm just going to find two numbers that I can multiply to give me negative 32 or add to give me 4. The multiplicative pairs here are 1 times 32, 2 times 16, 3, 4 times 8. I know I can manipulate these. If this was a negative 4, it would multiply to give me negative 32. And if I add them, they would give me 4. So that's what works. So I'm going to write P minus 4, P plus 8. Now that this is in factored form, I can determine that there are two solutions. One of them is positive 4, and one of them is negative 8. Those are the things I could plug into each of those factors to create a situation where when things are multiplied, 0 will be the outcome. Taking a look at this one, this is a little different. I know that I can factor out a 7n. So inside, this would have n minus 4. If I'm unmultiplying it, I'm factoring it, right? And even though this is a quadratic, my factors look a little different, but I still have two factors. Actually, I have 3, but we'll just look at these. For this one, in order for this factor to be equal to 0, n would have to be equal to 0. And for this factor to equal to 0, n would have to be 4. So there's two solutions, 0 and 4. Let's take a look at number 4. For us to be able to factor this properly, I have to make this be equal to 0. If it's equal to 0, then I can use that multiplicative property to be able to find the solution. X squared minus 4x is equal to 0. They cancel, the x cancel out on both sides. I factor out the GCF. In this case, it's x. Inside my parentheses, after factoring, I have x minus 4. So my two solutions would be x equals 0, x equals positive 4. That looked a lot like that last one, except we had a little bit of work we had to do to get to where we wanted to be, a little more. Again, for number 5, if I want to factor this, I'm going to start off by factoring out the greatest common factor, which is 2. That makes my life much easier because it will be easier for me to come up with 2 numbers I can multiply to get negative 14 or add to get 5. It has to be 7 and 2. In order for this to be a positive 5, the symbols would need to go in the way I just put them, positive 7, negative 2. So this factor doesn't really do a whole lot. N has to equal negative 7 to create a 0 here, and N would have to be positive 2 to create a 0 factor there. 2 solutions for that quadratic equation. Here I'm going to go ahead and set this equal to 0 before I do anything. And then I have to ask myself, 3 times 4 is 12. Is there 1 and 12, 2 and 6, 3 and 4? If I go ahead and I say negative 1 combined with negative 12, that will give me negative 13. So let's go ahead and break this up. 4n squared, we'll say minus 12n minus 1n plus 3. I'm using factoring by grouping where I split negative 13 up. In the process, I will be able to section these off and hopefully, I have to take the 4n, let me go back here a little bit. Right, 4n, n minus 3. I want to make this say n minus 3, and I can do that if I put a negative 1 out here. If I have matching factors, I can factor out an n minus 3, and what is left behind is 4n minus 1. Now, remember that this is also still equal to 0. I see that one solution is going to be 3. This other one, 4n minus 1 equals 0. Add 1 to both sides. Divide both sides for 4. This solution is positive 1/4. Can that happen? Yes, it can. It can happen. You can have a solution that is not a whole number or integer. You can have one that is represented by a fraction. So, that is interesting. That is one way that you can solve a quadratic equations by factoring. You also have another method that we can use called the quadratic formula. Notice that they did some color coding here. I love color coding. Here we have the standard form for a quadratic. That A represents the coefficient in front of the leading term. Notice that any number that you would find in that spot would get plugged into the equation where I highlighted. The B has its own little place here. And then the C only has one spot. We have to plug it in right there. All we do is go through the motions to simplify this as much as possible. And then we can go ahead and solve. This we use when we have numbers that are not perfect. And we'll talk about that more. Even better, they have a name for this little situation we have going under the radical symbol. We call this the discriminant. And the discriminant can actually tell us some clues about what's going to happen. Discriminant, I'm pretty sure I didn't spell that right. And then I wrote can't. It works. It's right here if you want to know how to spell it properly. If this number, whatever it is, after I put it in, is greater than 0, then that indicates there's 2 real solutions. If it is equal to 0, that means there's one solution. And if it's less than 0, then there are no real number solutions. So that's really just kind of an interesting little doohickey. I'm going to do the first couple here. In order for me to interpret this property, I need to make sure that I have this set equal to 0. So I have to add 5 to both sides before I determine that A is going to be 2, B is going to be 12, and C is going to be 5. I wanted B to be green. And then what I'm going to do is I'm going to go ahead and write out that formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All the things I'm going to plug in are going to be in the A spot, the B spot, and the C spot. So let's go ahead and do that. I have x is equal to negative 12 plus or minus, I'm going to put 12 in a set of parentheses, minus 4 times 2 times 5, all over 2 times 2. 12 squared, just so you know, if I were to put this in my calculator, 12 squared is 144. And this is going to be 4 times 2 times 5, which is 40. So I know that under this radical symbol, I am going to have 104. Positive number means there's going to be 2 real solutions. So that's just an interesting little thing. I am going to go ahead and write this as negative 12 plus or minus the square root of 104 over 4. Now, if I could simplify 104, that would mean that I have perfect squares that I could pull out of it. So I'm going to just see really quickly, 1 times 104, 2 times 52, 3, 4, 4 times 26, 5, 6 times 7, 8, 8 times 1, 3. These are all of the things. I'm looking to see if I can pull out a perfect square number. Here's a perfect square number, 4. 4 is a perfect square number. So I can go ahead and say negative 12 plus or minus. This can be broken down into 4 times 26, and the square root of 4 is 2. That's it. So I'm actually just going to leave this like this. I'm sure I could simplify this maybe further. Actually, when I look at this, I really could simplify. Yeah. We'll just leave it like that. Sometimes when you have these in WebAssign and they're asking you to do these, they'll ask you to express the answers. There's 2 solutions, BTW. One of them is negative 12 plus 2 radical 26 over 4, and one is negative 12 minus 2 radical 26 over 4. They might ask you to give these answers in the form of a decimal, and if they do, do it, but just make sure that you're doing it in a way where your rounding is correct and you have both answers. For number 4, I'm just looking at this. The A is 1. There is no B term. There's no X term, so I'm going to put a 0. C is negative 24. All you're doing every single time is plugging these numbers into the quadratic formula. It doesn't change. This one here, number 2, if I was going to go ahead and put this in, this is my A, my B is 1, and my C is negative 1. Here, I have to make sure I move all of the things over to one side and set it equal to 0. So I subtracted 5 and I subtracted 3x. A is 2, B is negative 3, and C is negative 5. You again are going to plug that into the quadratic formula and use that as a way to solve. This formula works for every single quadratic equation that you have. Every single one, it will work every time. Sometimes it's less work, sometimes it's more work. Some people absolutely never use it if they can help it, and some people use it for everything. It's just a preference, really. So this is the end of this video.